Elon Musk may have finally designed an engine that breaks the speed of light. Scientists agree that interstellar travel is necessary for humanity's survival. Better understanding of the cosmos and finding new planets that can sustain life have always been the ultimate goals of space exploration. However, interstellar travel is not an easy task. The universe is huge. The distances to other cosmic bodies are immense. The closest star to Earth, Proxima Centauri, is about 25 trillion miles away. And with the fastest spacecraft ever, it will take us more than 6,000 years to reach it. Even our closest planetary neighbour, Mars, is about 34 million miles away and remains our best bet to start a human civilization on a planet other than Earth. Elon Musk founded SpaceX with the aim to colonize Mars. However, the journey to the Red Planet takes 7 months. So starting a self-sustaining human colony and constantly moving people to and from Mars remains a distant dream with current technologies. It is quite obvious that in order to become an interplanetary species in the true sense, we need to cut the massive distances of the universe short. Fortunately, NASA and Elon Musk are working on exactly that and may have finally designed an engine that breaks the speed of light. The conception of distances in the universe becomes much easier when measured with the speed of light. For example, the Proxima Centauri is 4.2 light years away from Earth. A light year is the distance light travels in a year, and if human beings can travel at that speed, space exploration will become slightly less complicated. However, reaching the speed of light according to laws of physics is an impossible feat. The speed of light in a vacuum is considered to be the limit of how fast an object can go, and even getting close to that mark presents barriers that are impossible to overcome. The reason is simple. As we approach light speed, we have to provide more and more energy to make an object move. For a spacecraft, we'll have to power it with more and more rocket fuel to propel it forward. But to reach the speed of light, an infinite amount of energy is needed, which is impossible. However, that hasn't stopped scientists from coming up with innovative solutions to the problem. One of the solutions is to use propellantless rocket engines. The idea was first floated in the 1970s by the US inventor Robert Cook, who proposed an engine that converted centrifugal force into linear motion. Fast forward 3 decades, and British engineer Robert Scheuer invented the EmDrive. It was a rocket engine powered by electromagnetic waves and eliminated the need for fuel to propel spacecraft into deep space. The proposal made worldwide headlines and was labelled as the impossible engine that broke the laws of physics. The principle at which the EmDrive worked was that microwaves trapped inside a conical cavity generate thrust. In a rocket engine, these microwaves would bounce off the walls of the engine and produce enough force to push the rocket in one direction. According to Scheuer, this thrust was produced without any form of exhaust, so the EmDrive practically broke at least 2 laws of physics. The law of conservation of momentum and Newton's third law of motion, which says that every action in the universe has an equal but opposite reaction. While most physicists remain skeptical of the EmDrive, the claims were further supported by a NASA experiment in 2016. A prototype built by a NASA team led by Harold White produced similar results. They found that the EmDrive indeed produced thrust that could not be explained even when they turned up the power. They saw additional thrust without any reaction in the form of an exhaust. Even Elon Musk commented on the EmDrive via Twitter, saying, "While I like the initials, I'd take the so-called EmDrive with a grain of salt." Just as the excitement was building around the EmDrive, a team of scientists from Germany's Dresden University of Technology published a paper disproving the claims made by Robert Scheuer. They concluded that the results produced by NASA and Scheuer were false positives and didn't take into account the magnetic fields produced by electric wires feeding the EmDrive. Without those magnetic fields, there was no thrust, and hence no chance of wide-scale use in rocket technologies. Scheuer still claims that researchers got the designs wrong, leading to failed tests. Whether the EmDrive will work in the future or not remains to be seen. In the meantime, however, there was yet another proposal for a reactionless propulsion drive that claimed to make interstellar travel possible at speeds reaching levels close to 99% of the speed of light. In 2019, former NASA engineer David Burns came up with the concept of helical engine, which he claimed could work without using a propellant. Burns used the example of a ring moving back and forth on a rod inside a box with elastic walls. Each perfectly elastic collision will impart momentum to the container of the box. According to the theory of general relativity, objects gain mass once they start moving closer to the speed of light. Using that principle, if the ring is accelerated in one direction relative to the other direction inside the box, it should have more mass when it moves in that direction, and therefore it will continue to accelerate the box in that direction. For a rocket engine, Burns proposed switching the box with a helix-shaped accelerator. In this accelerator, ions replace the ring and move in a loop. The ions will then move faster at one end of the loop and slower at the other, generating a net thrust in a preferred direction. By shifting momentum to a preferred direction, the device will also bend the laws of conservation of momentum. Burns' helical engine would also be very large, reaching 200 meters in length and 12 meters in diameter. It would require 165 megawatts of power to generate just 1 newton of thrust, which is a lot of input for very little output. So this concept is extremely inefficient, and the engine would only be able to reach meaningful speeds in the frictionless environment of space. Will a helical engine eventually work out or suffer the same fate as the EmDrive is a question for the future. A more important thing to understand is that even if we do manage to travel near the speed of light, we will not get very far in the universe. We might eventually scale Mars and find out more about our solar system, but moving beyond that will still remain impractical. Which is why a much better solution for NASA and for Elon Musk lies in a Star Trek concept that has been around since the 90s. One aspect of Einstein's theory of general relativity states that mass and energy warp space-time, which means that heavy objects like stars and black holes curve space-time around them. Star Trek uses that concept and named it the warp drive. Inspired by the Star Trek idea, Mexican theoretical physicist Miguel Alcubierre proved that this warp drive was mathematically possible and didn't alter any laws of physics. In his paper, he demonstrated that a warped bubble created around a spaceship can compress space-time in front of it and expand it behind, shortening the distances in the process. In essence, a warp drive brings the destination towards the traveler by compressing the space in between. The concept is truly revolutionary and theoretically possible according to Alcubierre. NASA has been working on the theory for years now, while Neil deGrasse Tyson publicly called out Elon Musk on Twitter, telling him to stop focusing on Cybertrucks and Mars rockets and instead develop a warp drive. Elon Musk seemed on board with the idea and even acknowledged in an interview that space was a much faster way to travel than light and possible in theory.
Space itself move. That's warping space. Space is capable of moving faster than the speed of light.
Right.
Like the universe in the Big Bang, the universe expanded at much more than the speed of light, by a lot.
Yeah.
However, Alcubierre's drive required negative energy and negative mass. To create negative energy, a warp drive would need a massive amount of matter. And according to Alcubierre's model, creating only a 100-meter warp bubble around a spaceship would require the mass of the entire universe. This problem was more recently solved by Eric Lenz, who used different geometrical models to prove that spacetime can be modified within a warp bubble without the need for negative energy. For the longest time, warp bubbles remained a figment of scientific imaginations. However, recent developments are bringing the concept much closer to reality. And who knows, maybe a Star Trek future is closer than we think.